Some string-related built-in functions. There are several functions that deal with strings that are built into Python. We won't review all of them, but some of them here. To begin with, there's input, stir, and len, all of which we've seen, but let's review them here. Input takes a string, which is the so-called prompt. It will present the string to the user. The user will enter some text in response, and input will return that text, which we can then assign into a variable. Len will take the length of a variable, and stir converts its argument into a string. Since len is an integer, we have to take the stir of the len if we want to actually treat that as a string, which we're doing here because we're using string concatenation. So we go ahead and run this. Enter your name. My name is David. I say OK. And now it says, hi David, that's hi name. It stored the name in the name variable. Your name has 5 letters, D-A-V-I-D, 5 letters, because the len of my name was 5, and converted that to a string, and then used string concatenation to place that in here. Fine. Char and ord. So Python, like all languages, stores values as integers. Ultimately, everything when it hits memory is going to be stored as ones and zeros. So really, integers are what we need to store values. So how do we store characters? How do we store the letter A? And the answer is with a code. In the old days, that was ASCII. In the new days, it's Unicode. But the code is the same for the standard keyboards on standard characters on a Western keyboard, which is to say A through Z, 1 through 0 for the digits, and so on. Pardon me, I should have said 0 through 9. So the punctuation that we've seen, these will be standard codes for every version of Python that you run. In particular, capital A is 65, and this is because of ASCII, A-S-C-I-I, ASCII, which is an old code to do this exact thing, to map characters to integers, has capital A 65. Fine. So ord is a function that takes a single character and gives you back its ASCII code, or its Unicode value if it's not ASCII. But it gives you back its code. Okay. Ord stands for ordinal, which means the integer order of this value. Anyway, ord of a character, and then char, C-H-R, is the inverse of ord. Char takes some integer, which is like the ASCII value, and turns it back into the actual character, in this case capital A. So these are useful at times when you want to say deconstruct a character sequence and manipulate the letters by shifting them, for example, which is exactly what we're going to do right here. So if I have the ord of capital A, I'd get back 65. I'd add 1 to get 66, and I take care of that, which gives us capital B. In fact, I could have done +2 here and gotten capital C. And I could have, instead of having capital A here, I could have put this in a variable like capital A. And now let's get rid of these 2 lines, which aren't really helping us anyway. And we'll do it with a variable. And we'll do +1. So now run, and there's capital B. I could say this is capital W and it's capital X. So I could, for instance, say now for C in wow. And now when I run this, I get the letter after capital W is capital X. The letter after lowercase o is lowercase p. The letter after lowercase w is X. And the letter after, or the character after exclamation turns out to be double quote. Not that that's especially interesting. So this looks like a simple way to encode some text if I had, right, this is a secret. Let's go ahead and say, this looks like a way to encode, and it's pretty good. We do have a problem that, for instance, the letter Z does not become a Z, but that's not a terrible problem. If you wanted Z to become, if you wanted Z to become A, you'd have to wrap around so that this would go to A, and that's an interesting homework assignment. In any case, char and ord allow you to go into and back out of ASCII given, or into Unicode given a particular character. Eval. So if I have a string of valid Python, I can call eval on that string and it'll run that Python and give me the result. So here is a Python expression. It's an expression, 3 squared plus 4 squared, square root, which naturally will be 5. And sure enough, when I evaluate it, I get 5. So this looks great. This looks pretty handy. You might, for instance, ask the user, enter an expression and I'll run it for you. You get this from an input prompt, you call a val on it, and you print the answer. What could go wrong? Well, what if they entered reformat my hard drive? Well, we actually do that right here, and when we eval it, it says, I've never heard of reformat my hard drive. But there are valid Python commands you can give that in fact would ultimately reformat a hard drive or remove all the files off your hard drive or do all kinds of malicious and bad things. So the answer is this is an egregious security risk and you should simply not do it. The only way that you should ever use a val for a novice programmer is if you yourself constructed the string and you are certain that it's not going to do anything dangerous. And in particular, under no conditions should you ask for a string from the user or get a string from any untrusted source and then call a val on it, because all bets are off. And you can have the best antivirus and security software in the world, and it won't catch this because you have your system configured to allow your code to run on your system. Now, one piece of good news is when you're running your code inside Python, you're in the so-called sandbox, and nothing bad can happen, to tell you the truth, inside your browser. But mostly you're going to be running code in standard Python. And when you go into your standard Python here and you run the code here, if you say to reformat your hard drive, you now have a reformatted hard drive. For these reasons, do not use eval. Even if you see lots of people using them, using eval in the wild, we strongly disrecommend it.